Hi everyone. Today's lesson is on solving with square roots. So we're kind of diving back into the world of equation solving here, and we've been working on equation solving kind of intermittently throughout the year. That's a concept that kind of permeates a whole bunch of different algebraic topics. So solving an equation of any form is going to be really important for you moving forward. Today, the step that I'm going to throw in that you maybe haven't seen before is what do we do with powers, exponents, and specifically in this chapter, we're talking about quadratics, which means squares on your variables. I don't think that that extra step is going to be a huge stretch for you. In fact, many of you probably already have an idea of what to do. However, there is one piece of that's going to get a little bit complicated. So make sure you stay with me. Make sure you're writing down my steps here. Before we dive in, I just want to remind you that equation solving in general is all about undoing things. It's all about unwrapping that variable and figuring out what its value is. So you hear us talk about PEMDAS when we're evaluating mathematical expressions, right? Order of operations. So parentheses and then exponents, multiplication and division go together, addition and subtraction go together. When you're solving equations, you're trying to undo these steps. So when you're solving equations, you actually do this in reverse, and you're going to hear me refer to this as SADMAP. Okay? It's the lesser known cousin of PEMDAS. So this is the order that you tackle things when you're dealing with equations. Is first you get rid of any sort of subtraction or addition, okay, together, because those two steps are equivalent in terms of the order. Same with multiplication and division. Then we're going to get rid of any exponents. And then if we have any parentheses, by then those parentheses should have been cleared out and we can dive into them and kind of start all over again. Okay, and you're going to see that process in a few of these problems here. So just to kind of illustrate that point, when I look at this problem here, I've got a square to deal with and I've got a plus 3 to deal with. You always want to take care of the addition and subtraction first, meaning you want to get rid of it first. So where I see a plus 3, I want to subtract 3 on each side. Okay, that step probably isn't, rocket science for you, but knowing to do that first is going to be important. And then 28 minus 3 is 25. And so here's the step that's technically new. Now we've got an x squared, and we're trying to get rid of the square. Equation solving is all about undoing things. So how do you undo a square? Well, hopefully you're saying to yourself that you would use a square root. Okay, squares and square roots are opposite of each other. And so if I take a square root, it's going to cancel out that square. Here's the piece that might be a little bit different for you. When you take the square root of a number, technically there could be two answers. When I say that x squared equals 25, I'm asking myself, what number could I square to get 25? And for most of you, probably your answer is going to be 5. In fact, if you were to type this into a calculator, your calculator would tell you that the answer is 5. And that is true. Okay, so one possibility is x equals 5. But keep in mind that if I took the number -5 and squared it, I would also get 25. So I have to include the possibility that x could also be a -5. And so to get this question right, you have to have both of these answers. You have to have the x equals 5 or the x equals -5. If you're missing one of those two, you will not get full credit, okay? Because there's two possible solutions to these problems. All right, so let's look at this one. Thinking about SADMAP, the first thing I want to get rid of is that -2, so I'm going to add 2 to each side. And so now I have 4x squared equals 144. And then I want to get rid of multiplication and division, right? So that would include the 4 that's sitting out here. So we have to get rid of the 4 before we take a square root. Really, in a lot of these problems, the square root is going to be almost the last step that you take. Okay. Oh, let's see. 144 divided by 4. Oh, let's see. I think that's 36. So x squared would give me 36. And then I'm going to take a square root. Hopefully you know this one off the top of your head, but if you don't, you could use a calculator. Just remember, your calculator is only going to give you the positive answer here. So from here, we would have to say x could be 6, or The other possibility is x could be -6. Okay, have to have both of those answers. You can shorten this up a little bit. You could write this up here like this, x equals plus or minus 5. You could write this one as x equals plus or minus 6. That kind of builds in both of those answers. There's going to be some down here where the two numbers do not come out the same, where your positive and negative number aren't necessarily the same at the end. And so that's why I kind of try to drive this point home that this is two different answers so that it's not confusing later on. But you can use that shorthand. I'm okay with it. Okay, now would be a great time for you to pause the video and try this next one on your own. Okay, I'm going to keep going, but I would love for you to pause it, try it on your own, and then see if your answer matches mine. And now that I think about it, this may have been a bad one for me to tell you to do on your own. Didn't realize how the answer was going to come out here. So let's subtract the 5. There is something weird that happens with this one. So if you got stuck trying it on your own, I apologize. Equals -2. Now I have to get rid of that 1/2. I don't like to divide with fractions. Instead, I multiply by the reciprocal, which is 2/1. And we know that 2/1 is really just 2. So 2/1 times 1/2 cancels out. And I get -4. And then I need to take a square root. Okay, so let's think about this. What's the square root of -4? What could I possibly multiply by itself to get -4? My guess is, don't write this down yet, but my guess is the answer that's popping into your head is -2. Okay, well, hey, that's negative, right? So wouldn't the answer just be negative? But think about that. If you took -2 and squared it, it would not come out to -4. It would come out to +4. Okay, so this is not a valid answer. And we know it's not +2. So what is it? The truth is there is no square root of -4. Okay, at least not in the real number system. We're going to be talking about something later in this chapter that kind of addresses that issue. But you can't take a square root of a negative. No real square root. Of a negative number. You don't have to write that, every time. I'm just kind of pointing that out, that anytime you end up in this situation where you're taking a square root of a negative, because the only way to get a negative would be to multiply a positive number by a negative number. And by definition, a square root needs to be 2 of the exact same numbers. Okay? So realistically here, like I said, I wrote this here so you would understand why the answer is what it is, but I would typically just write no solution for this one. That's going to happen anytime you're taking a square root of a negative. But you can't make that call until you're at this step right here, okay, where you're about to take the square root. Notice that back here, I couldn't tell that this thing was negative, okay? In fact, that's why I turned you loose to do it on your own, because I figured it would just come out like the others, and it did not. Okay, so let's look at this next one. And for this one, I really want you to focus on SADMAP here. And the other thing I want to have you avoid, I know we just came off of a lesson 6.1, where we were taking these things and foiling them, right? We were taking the two parentheses and multiplying them together. That's when we were simplifying and expanding and just trying to make things look pretty, okay? With equation solving, we're not trying to make things look pretty. We're trying to get rid of stuff, okay? We're trying to dig this x out of here. So if I FOIL, that's going to expand it and make it larger and messier, and I'm not going to be able to solve it, okay? So do not FOIL in this situation. Let me put a note here that for these problems, when you're solving, do not FOIL when solving. Okay, foiling makes the mess bigger, and solving is all about cleaning up the mess. So again, let's refocus on SADMAP. Now, it says to get rid of addition and subtraction first, and I do see subtraction, but that subtraction is trapped inside these parentheses. I can't touch anything in the parentheses until the outsides of the parentheses are cleared out. So I'm not going to worry about that -5 right now. I'm going to go to my next SADMAP step, and I'm going to do multiplication and division, which would be the 2 that's on the outside there. So I'm going to divide by 2 on each side. That leaves me with x minus 5 squared equals 4. Now, I'm still trying to get those parentheses by themselves, right? I'm still trying to get inside those parentheses. And so the next thing I need to get rid of then is the square. So we know the next step. To get rid of a square, we're going to use a square root. And I'm going to remember that when I say the square root of 4, and that's positive, so I can find an answer here, that it could be 2 or negative 2, right? Those are both possibilities. So what I'm going to be left with here is x minus 5 could be positive 2, or x minus 5 could be negative 2. Actually, I'm going to get rid of that or so that I have room to do my solving here. So this looks just like these first two that we did, except that I have an x minus 5 left over here at the end. It's not just x. That means I have one more step that I have to use to solve. So when we do SADMAP, once we get to these parentheses, then sometimes we have to start all the way back over. Okay, then we start back over and work with whatever's inside the parentheses. So inside the parentheses, I have an x minus 5, meaning I'm going to add 5 to each side to get rid of it. And I'm going to do the same thing down here. And this is going to be one of those situations I mentioned where the two numbers don't necessarily come out the same. So here I'm going to end up with x equals 7. And here I'm going to end up with negative 2 plus 5 is 3. So x equals 3. So these are my two solutions. So I still came up with two solutions. They're just not, it's not a plus or minus of the same number. Okay. Sometimes I'll see people go all the way to this step, they get all the way to the x equals 7, and then they go, oh, wait a minute, I was supposed to have two answers, and they try to just turn that into a plus or minus. That's not going to work for you when you have these parentheses in here, because you're going to get two different answers. So you have to do the split right here where you take the square root. Okay, so the next one has just about every step I could ask of you in it. It's got numbers outside of the parentheses, it's got numbers inside of the parentheses. Remember, start with everything outside of the parentheses, addition and subtraction first. So I'm going to get rid of that plus 8 first. That's my first goal. So I'm going to subtract 8, and I'm going to subtract 8. So now I have negative 2 times x plus 3. You could pause the video if you wanted and get a head start on me and see if you can get the answer to this one. Equals negative 18. I'm still working on the outside of the parentheses, so let's get rid of the negative 2 by dividing by negative 2. Remember, I'm not foiling, I'm not distributing here. So x plus 3 squared equals 9. If you're still with me, take a second and think about what our next step should look like. I'll give you a hint, it's not FOIL. I need to get rid of the square, so I'm going to take a square root. And as soon as I take that square root, that's where I break out my arrows, right? That's where I know I'm going to have two possible answers. I'm going to be left with x plus 3 on the left, no matter what. Okay, that's what's going to be left here, is the x plus 3. And then square root of 9 could be 3, or square root of 9 could be negative 3. So now I'm going to solve each one of these. Subtract 3, subtract 3. Do the same thing down here. I'm just doing that so I don't have to keep switching colors here. This one ends up at x equals 0. This one ends up at x equals negative 6. So there are my two answers. So every single one of these problems is going to have two answers unless it's a no solution. And remember, the no solution comes up when you take a square root of a negative number. Okay. That's the bulk of this lesson. There are a couple other things I'm going to talk about in just a minute, but these examples are really, really critical for what you're working on today. So I would make sure that you have these down, rewind, go back over, any part of this that you need to see again. Okay. This next part, quite honestly, is probably not going to come up on your homework today, but it is going to come up when we start to get ready for your quiz that's coming up probably later this week. So got a couple of definitions there for you, rational and irrational numbers. And really, I think we talked about these earlier this year, but the difference is rational numbers can be written as fractions. Irrational numbers are numbers that cannot be written as fractions. So how do we know if something can be written as a fraction or not? I mean, if it's a fraction already, that's really easy, right? And if it's a whole number, we know we can write it as a fraction because we can put it over 1. Okay? The difference is going to come with the decimals. The decimals is where we're going to have to ask ourselves some questions about, is this rational or not? Decimals that either, sorry, I don't want to talk and write at the same time because I'll screw it up. Decimals that terminate, which means they end, or repeat, can all be written as fractions. Okay, so if you have a decimal that is nice and short and it ends cleanly, we know that's a rational number. Okay, if you have a decimal that goes on forever, so it doesn't end and it doesn't repeat, that's an irrational decimal. The most famous example of that, by the way, is pi. Okay, we all know the decimal pi goes on and on forever. Okay, the decimal places go on forever. But then there are also quite a few numbers that when you take the square root of them, so like the square root of 20, let's say, that number is going to come out to be irrational. And I'll show you why. I'll show you why as soon as I get my calculator out. Sorry, I was not prepared for that. Any number that's not a perfect square. So a perfect square would be, I mean, quite honestly, the examples that we did on the first page all had perfect squares in them. The square roots came out nice and clean. But if I do the square root of 20, I get this big, crazy, ugly decimal. Now, on your calculator, that looks like it ends, but your calculator just only has so many spaces for numbers, right? So if you have a decimal that goes all the way to the end of your screen on your calculator and you're not seeing any sort of repeating pattern, you can assume that that decimal goes on forever. So this is an irrational number. This decimal, I mean, if we were actually calculating the square root of 20 by hand, this number would go out forever and ever and ever. So we just want to run through these real quick and decide whether they're rational or irrational. And if you want to pause and try these on your own first, oh, look, I am not creative at all. That example is right there. But if you want to pause and try these on your own, that's a great idea. Okay. Anything that's a whole number is automatically rational because they can be written as something over 1, and that makes it rational. Square root of 16, that comes out clean, right? Because 16 is a perfect square. So if I were to type square root of 16 on my calculator, it would just tell me it's 4. That is also rational. But for the reasons we just talked about, square root of 20 is not a perfect square. That is going to be irrational. Can't decide what I want to use as an abbreviation there. 0 is rational just like the 3 was, because you could put it as 0 over 1 and call it a fraction, so that's rational. This 3/5, that's already a fraction, so I'm happy with calling that rational. This decimal is a nice clean decimal, right? It terminates. And so the reason that works out okay is I could really think of this as negative 24 over, and this is in the hundredth spot if you go back to elementary school, okay, with decimals and place value. So because I can write that as a fraction, that makes this thing rational. This guy, though, those 3 little dots, tells you that this decimal goes on and on forever. So this number would be irrational. And this number. There's really no way to tell from looking at a big number. I mean, hopefully the smaller perfect squares like 16, you know off the top of your head. I don't know whether this one is rational or irrational. I'm going to have to type this into my calculator. So 60025. By the way, that square root button is up above the square key, okay, in case you didn't see that what I did there. And because that comes out as a nice clean whole number, I would call that a rational number. Okay, so just a quick little reminder of what it means to be rational versus irrational, because that does come up later in this chapter. And then example 3. And again, this example is going to be one that you're going to want to refer back to when you're looking at your quiz review later this week. A circle and a square have the same area. So let's draw our circle and our square. So here's my square. Here's my circle. Okay, and their areas are the same. The square has a side length of 8. And I want to know, what must the radius be of this circle? What's this radius? To make it so that the areas are the same. Well, let's think about what the areas of each of these shapes would be. To get the area of a square, we just do 8 times 8, which is 64. So area equals 64, and that would be square units, whatever the units happen to be. For a circle, I mean, I don't know what the radius is, but I know how to find the area. I know that the area would be pi r squared. Hopefully you remember that from geometry. Okay? And we want this to equal this. So the equation we're going to set up is 64 equals pi r squared. And then I want to try to figure out what r is. Okay, remember SADMAP here. I don't want to jump in and start taking square roots of things, right? Because I have to get rid of this multiplier first. And pi is really just a number. It's an irrational number, but I can work with it the same way I work with everything else. So before I do anything, I have to divide by pi. I'm going to have to use my calculator for that, and it's going to come out ugly, and that's okay. So 64 divided by, if you're new to these calculators, the pi button is right here. It's above that little caret key that you use for exponents. So second pi, 64 divided by pi is 20.37. You'll notice that when I write this down on my paper, I'm just going to do I'm going to round that decimal. But when I go to do this next step, which is to take a square root, I'm going to use the whole decimal in my calculator, and I'm going to show you how to do that. So I'm going to take the square root of, and then to get my calculator to bring that same number down, I'm going to use that ANS button. I think we've talked about this earlier this year. But right here above the negative sign, you'll see this ANS, and that just pulls down the number that I had saved from before. So I'm going to hit second ANS, and that's going to take the square root of that whole decimal. Now, normally I would do this. I would say it could be positive or negative of that number, right? In this case, because it doesn't make sense for a radius to be negative, I really don't have to worry about having the positive and negative answer. Mathematically, that answer still exists, but I can just say, 4.51 equals r. And did it tell me, oh yeah, rounded to the nearest hundredth, so I rounded that correctly, 4.51. Okay, that's about it for this lesson on square roots. Hopefully that wasn't too earth-shattering for you, kind of warming you back up here as we jump into some more stuff with quadratics later in this chapter. All right, good luck.